All right. So today it's the Packet 5 class 26. Last week, not a whole lot going on. This week is huge. There's only 3 of these weeks in a semester, 3 test weeks. First one we had in February. Now we have this one in April. The next one is not till finals. So there's only 3. This is where most of the points come, of course. So what's going to happen? Well, tonight, I'll be right back here at this Zoom channel, sitting right back in this chair, and I will be going over problem by problem in chronological order. Because students complain, you know, they come back, they don't have time to watch the whole thing. They don't have time to be there Monday night. They got to work, right? They're working over there at Chick-fil-A or something, and they can't be doing this. So they want to watch a recording. And if it's not in chronological order, then it's recording. You know, they have the question about number 4. So I'm going to put it in chronological order, just for those that are watching the recording. So if you can't make it, then just watch the recording, say, you know, sometime late Monday night or Tuesday. The thing is due Tuesday night, the take-home test. Submitted PDF, please. I mean, picture's okay, but save it as a PDF because I got to be able to read it. Some of you just do beautiful PDFs. Some of you are pictures and it's all dark and shadows. I can't read the daggone thing. Trust me, you don't get as many points when that happens. You're going to have to make it so it's readable. Okay, so that's due tomorrow night. We'll meet tomorrow as usual. It'll be our last official day of Packet 5. Then the 7th, Wednesday, is Flex Day. And for us, we'll still meet 1, 10, and 2 o'clock. But what we're going to do on Wednesday, for the benefit of all students, is I'm going to produce the video key for the take-home test. Tonight, I'm giving you hints. I'm showing you a step or 2. I'm sitting you in the right direction. I'm answering your questions. But Wednesday is here's how to work step by step every problem on the take-home. Now, you've already turned it in, right? You've already submitted it. You cannot, if you submit it again on Wednesday, you automatically lose 30%. You're going to lose, what is it, 30, 45 points. Boom, 45 points lost. So because that's to keep people from waiting until the video key is produced, then watch the video key and get a 150 out of 150, where some other honest student did it Tuesday night and got a 120 out of 150. That didn't, you know, and I'm not checking that you have the exact right answer. I'm looking at, is it thorough work? Do you make sort of sense what you're doing? And if you're going to still get credit for it if you made mistakes. I might spot check, but you're going to get most of the credit if you turn in a solid take-home test Tuesday night. So that only applies. That video key, though, you do need to check that video key on Wednesday, because you want to make sure you're studying the right stuff. I don't want you studying the wrong stuff. You may have worked every problem wrong on the take-home test and still get credit for it. Okay, so our new student has joined us from Texas. It says Ked Monson Hardwick. Can you turn your audio on for a second? You don't turn your video on, but turn your audio on and tell us how to pronounce your name.
It's Caden Edmondson.
Caden. Oh, so K Edmondson. So Caden. Yeah. Now, Caden, you probably want to eventually get an icon for yourself. It doesn't have to be a picture of you. It could be anything. Like Brandon has a cool, you know, some landscaping there. So Caden, everybody say hello to Caden. These are all virtual students. Students also get on here if they miss a class, they'll jump on. You're in the Caden, you're in the live presentation. You can always, I'm going to record this. I am recording this, and there'll be a video of this, what we're doing right now. It'll be available about 2:30 this afternoon, and you can find it on the Canvas and modules. You can also find it on the Facebook. I saw you joined our Facebook group today. You'll find it in guide number 1, first guide. You'll see screenshots from today, and then it'll have in the first comment, we'll have a link to this video. So if we go over something that doesn't make sense, which will probably happen because you don't know our lingo yet. Okay, so welcome. Okay, you can turn your, here you go. All right, so that's Wednesday this week. We will meet, but it'll be to do the video key. We will not meet on Thursday, and we will not meet on Friday. So just today, tomorrow, Wednesday. Friday, I need to add this in there, my bad. For virtual, the virtual students on Friday, you all will get your test it'll be available at 2 p.m. 2 p.m. And then you're going to turn it in. That's the test. That is test 5B. And you have until 6 p.m. Saturday. Now, obviously, Caden, you can take it if you want, but you ought to take it. I won't count it against you, just so you can have some practice at what a test is like in here. All right, so it's a 300-point test. We will not meet Thursday. We will not meet Friday, but you can come by my porch if you want to pick up the test. I will email you the test. I will email it at 2 p.m. But at that point, it'll also be available on my front porch if you don't have a printer or whatever. Okay, more about that later. Okay, what else we got? Shameless plug. We do have on Wednesday, Thursday night, all you juniors are taking the SAT next week. And so we have a prep course available for you, my company that does these things. And that's Wednesday, Thursday night through Zoom. And there is the flyer for it. So sign up for that if you want to. I think we can. I have 2 award-winning teachers that are really good at this, and they'll be working with you through Zoom. And then after that, 2 weeks. It's really, to tell you the truth, I don't look much past test week, so there's not a whole lot lined up for the next 2 weeks. I mean, we'll be doing stuff. We do start packet 6 on the 12th. And I'm not going to lie to you, packet 6 is the hardest packet of the year. Yeah, I mean, you just can't, it's physics, right? What are you going to do? 14th, Wednesday of next week will be the SAT test. So will we meet? Yes, we'll still meet, but it'll be for like 25 minutes. And it'll be kind of like we did last time where I'm going over something with you. I can't introduce anything new. And then maybe we'll look at rockets or something. We'll do something that day for about 20, 25 minutes. And the only other thing coming up, the next big thing after the test is the sample problems, for test 6A, the QR coded stuff. That'll be available Wednesday night, the 21st. Now we're talking way in advance. I put this pick up because my seniors, those of you that are seniors, you've had a rough 4 years. This was when you were freshmen, when Oklahoma, we all walk out, the teachers walked out. This is my wife and I at the Capitol, and everybody had signs where there was thousands and thousands and thousands of teachers. So that blew 2 weeks of school we didn't have. It's crazy. That was 3 years ago. Then 2 years ago, it was somewhat normal, I guess. Then last year was crazy because of COVID, and this year's been crazy. So seniors have had it rough. Okay, here is the packet organizer. I have extras of these. I realize now I look them at school. I'll put some on the front porch if you don't have a printer. This is not due for you guys till Saturday. So I'll try tomorrow. Probably I'll try and bring home some of these from the front porch. But if you want to print off, you can print off a color version or a black and white. But this is what's due Saturday, all of these papers, okay, 5-1 through 5-11. Now, no, we're not going to get 5-11 done. We'll just get started on that one. That'll become 6.1. I'll fill these in. Now, the dyno points you don't get. What you guys have been doing is you've been submitting stuff. And I gave some of you a 30 out of 20 on the last one, so you already got some bonus that way. Okay, the bonus really doesn't affect you. I guess 5.2 you might get some bonus there, but 5.4 that's bonus from the lab in the hallway, and 5.9 was duck walker bonus. All right, so a new innovation here for 4th 9 weeks is now on the take-home test, which is guide number 3 on the Facebook group. I have the problem there, and then there's areas to comment, but below it, for the first time ever, I'm giving you answers. Now, if it's a numerical answer, it's easy, 17.6 meters per second, something like that. But if it's not, I'll try and give you some guidance. And so here's my guidance on number 6 on the take-home test. I went ahead and gave you the answer, but you got to show me how you got that answer, okay? So just to let you know that you're doing it right. I hate working a problem and not knowing if I'm right. So this at least will allow you, if I make a mistake and you catch it and I'm way off, then you're gonna get 5 Facebook points for fixing that. So all the problems now are answered on the Facebook. Another thing I'm doing now, I can't show you this too strongly here, but on problems like on take-home tests and stuff, I'm going to start showing it to you step by step rather than just show you a key, right? Because the whole thing worked out. It's like, what the heck's he doing? Rather show you maybe the 5 or 6 steps that it took to get to that key. So you see it one step at a time. Okay, so it takes a little time to put that together, but I've started doing it on the take-home test. You'll see that tonight, part of it. And then the rest of it you'll see on Wednesday. Okay. So, take-home test. We're doing some feasting. If you guys, we're going to do a feast and film on Friday, and if you want to show up Friday for the feast and film, we watched this thing on Einstein, and this is on Emily de Chatelier, the film this time. She's Emily de Chatelier, I think, is the coolest woman ever lived, and we are doing a thing on her Friday. And we're going to feast. So if you want to bring on brownies or cookies or something, make something. And then trust me, we would love to have you in first, second, or third hour to watch the movie and to enjoy the feast with us. You're working as hard as anybody else. You deserve it. Did a dino hunt today. Joke Monday. Okay. Suitcases we talked about on Friday, that all these things we're learning, all these concepts go into suitcases, and the suitcases get bigger and bigger the further you go into physics. Einstein, when Einstein died, I don't know if I start telling the stories over and over again. Someone stop me if I've told the stories. But when they went into Einstein's room, he was an old man, he was still working. They had to pull the pencil out of his hand after he died. And look at what he's working, kind of shaky handwriting. He was still working on the gut, G-U-T, the gut. The gut is the ultimate suitcase. It stands for Grand Unified Theory. And we still don't have it today. Einstein went to his death. Stephen Hawking also worked on the gut, just couldn't do it. So the most brilliant minds on Earth continue to work on this largest suitcase possible. It's a theory that unifies all aspects of energy, not dark energy, but all energy that we can account for. And we're not quite there yet. We've gotten electricity and magnetism. That's electromagnetic. We got the weak force in there. Well, the problem is we don't have yet. We can't get gravity in there because gravity's so weak. Here's an example of suitcases. This is Maggie, Maggie Burrows. She's an artist, but she was a great physics student. She had the best notebooks. It was amazing. You guys have amazing notebooks too. She was big. Here's her suitcases. So this was her actual work suitcase. Inside there fit the force. Inside there fit, you know, the momentum, et cetera, et cetera. You keep opening like nested dolls. You keep opening them up till you get to the basic elements. So that's the idea behind suitcases. This is last week. We talked about this. We talked about how you got to F equals MA. We looked through all the graphs and all the data from the hallway activity, and we came up with first hour came the closest with only a 5% error. Okay, then Friday we did this. We finished the back of 5.9. We derived from Newton's original law. We derived his modern day law. Worked a couple of problems. And then, oh, here's something that came out of that. So this is going to be on your next equation sheet. By the way, oh, I scared her off. Okay, she left. Well, I was going to tell her that there are equation sheets on guide number. She probably said, okay, I'm dropping this class. That was good. Now I'm going to drop. It kind of sounds like a foreign language in here. Anyway, so this is the top of the sheet you're going to get. This is the 13th. I think this will be the 13th equation sheet. It's not finished yet. This is the top part of it. I'm still working on the bottom part. Probably release it next week or something. But this first thing, and I'm just giving you this, but it shows you how to get from Newton's original second law to his modern day second law. And then we have these magic triangles. Now, magic triangles are, you can call them a crutch, I suppose. But like for F equals MA, it comes in handy. If I want to know what the force is, you know, my finger covers, I don't have a finger here, but I cover the A with my finger, and that's force divided by mass. If I want to find mass, I cover the mass with my finger, and that's force divided by acceleration, et cetera, et cetera. Okay, so these are like little crutches, but sometimes it's good to have. Might be good to draw it on your next test. So weight, like your weight is F equals ma. Your weight is actually mass times gravity. The acceleration on your body is gravity. So weight equals mg. So a lot of times when I'm talking about a weight vector, which we'll do here in a little bit, I just show it as mg because that is the symbol for weight of an object. Now, my weight is 190 pounds. So let's go 190 pounds. And then you come up with my mass. What is my mass? Using the magic triangle, what is my mass? And you can type it in the chat or you can shout it out when you got it. What's my mass? I'll hit pause for a second. We're not in MKS. We're in FSS. Since I'm in pounds. Oh, well, yeah. Still, it's more than 8.8 kilograms. So. What do I use for my G?
Would you use 32.2?
30, thank you, 32.2 feet per second squared. When I do that, I get a mass of 5.9 slugs. Remember, FSS, F is feet, the middle S is slugs, the last S is seconds, feet, slugs, seconds, as opposed to meters, kilograms, seconds. So 5.90 slugs, that's my mass. I carry that with me no matter where I am in the universe, unless I'm close to a black hole. I carry that mass with me, okay? Or I'm going close to the speed of light. If I'm not doing those two things, I'm always 5.9 slugs. I made a vow to myself many years ago that I would never get above 6 slugs. I'm getting close, but I'll never get above 6 slugs. So you all now find out how many slugs you are. You're probably in the 4, 3.5, 4. I had a student that's 8 slugs. That's a lot of slugs. And I thought slugs was an ancient term, like it was probably used back in the 1500s or something. And then Brittany looked it up third hour. She said, no, man, since slugs, we started using that like 1905. Okay, so think about it. Newton comes up with F equals ma, or F equals delta P over T, but it's still force. So he didn't use Newton's for force. He didn't use pounds, I guess, because slugs, kilograms wasn't invented until the French Revolution, which is 1790s. Slugs, according to Brittany, what the article she read, wasn't invented until 1905. What the heck did they use for mass in the 1800s? I really don't know. Somebody do a little research on that, and I'll give you some Facebook points. What did they use for mass? What name did they call mass in the 1800s? Well, I guess they called it kilograms if they used the SI units. But for English units, what do they call it if they didn't say slugs? Anyway, so on these magic triangles then, a Newton is a kilogram times 9.81 on Earth anyway. This is just whatever G is. I mean, this is not going to be true on Mars, but theirs is like 2.6 something. But then on Earth, it's going to be, this is just for Earth, then it's going to be 32.2 for G on the Earth. Okay. So that's all well and good. Now let's go on to today's physics. Okay, so homework was number 1, and that's, we don't really talk about homework in class that much. I'm happy to talk with you on Facebook about it, but I want to keep kind of moving. So there's homework 1, and then 3 is also homework. 3 I assigned today. So I'll let you work on that. And eventually a key is posted. In fact, I'll tell you right now, a key is already posted to the front of 510. There's already a key posted on it. So try it and then look it up on the key. 4 is homework. This is our last set of homework was tonight. And 5 is homework. So we won't talk about that now. We're going to go on today. We're going to work 6 and start 7. And that's it. And we'll be done. I'm pretty sure, right? Yeah. So today, 6. Okay. Now, first thing I want you to do, you got to do an FBD, a free body diagram. So FBDs are pretty much every day from now until May, into May, we're going to be doing FBDs at some point. And that stands for free body diagram. Free body diagram. Meaning that we're looking at one body, one object, and we're looking at all the forces acting on that object. We're not looking at 2 objects, that's different. We're looking at one object at a time, free body diagram. So in this case, we're looking at the wagon. So Basil, I think he's living in Switzerland now, but Basil is pulling horizontally with a force of 20 newtons on a 300 Newton wagon. That's the weight of the wagon. Okay, that's the wagon's weight. My weight in newtons is around 900 and something. Okay, so that's the weight of the wagon. First thing I want you to do, and this is where we went to the board, so I'm going to pause in a second and let you guys go to your virtual board. And I had them do A, just A on the board, 6A on the board. Okay, so I'm going to pause it. And if you're watching the recording of this, you pause it. And I want you to try. Okay, we're pausing.
Are we taking into account normal force? Like, is that one of the forces we're putting on there?
Ah, see, you know more than the average bear. So here we go. Yeah, because in class, you know, they didn't. So here's what most people in class did. They said, okay, there's a force down, and that we call mg. That's the force on the wagon, and that is 300 newtons. Okay, as it says. There is a force of pull. I'll just make it to the right. This is not to scale. We're not doing head to tail here. There's a force of pull, and that is 20 newtons. But then there's a third force, and that's what people say, well, there's a back force. No, it says neglect friction. So it's not the back force. But Brandon is correct. There is this force, which we've just talked about a little bit. There is a force that is up. And it is the force. Without this force, you'd just fall through the floor. You're sitting in a chair right now, probably. You'd fall through the chair. There has to be a force back on you, right? And this is called the normal force. It's a lowercase n, not a capital N, a lowercase n, and it stands for normal force. Now, why the word normal? Normal, it comes from math. It's a math term, an old math term. It's a math term that means perpendicular. Perpendicular. So it's a perpendicular force. It's a contact force. It's not always straight up. It can be sideways. If I'm leaning against a wall, normal force is sideways, but it's a contact force. Anytime two surfaces touch, there's a normal force, okay? And that's what's on the, now in this case, I didn't draw it very well, but the normal force is congruent to, so if in a free body diagram, two forces are congruent, you got to show them as congruent. Sometimes three forces, but anytime you have congruent forces, you got to show the congruent symbol. So you'll have these two are congruent, these two are congruent, just to kind of help the reader see. So if they're congruent, they cancel, right? So if I take on this one, if I take summation of forces in the y direction, that's going to equal 0 up and down because nothing happens in the y direction because he's pulling his wagon. We assume he's pulling on a level surface. So that means that normal's up, minus mg is down, and that equals 0, which simply means that normal equals mg. Well, that's trivial, but okay. That's not going to solve our problem. We're trying to find the acceleration of the cart. So we have summation of forces in the x equals max. Okay. Well, in the x, I only have one force. I got the force of pull, and that's going to equal max. So I'm trying to solve for ax. That is then force of pull over the mass. Well, force of pull is 20 newtons. What's my mass? It's not 300. I need the mass of that wagon. I got to go back to this right here. Right? 300 newtons would go up here. And then I divide that by 9.81, and that's what I'm looking for. I'm looking
So it's like 30.6 or something.
That sounds about right. So you got to pull the math. You got to get the G out of it. So you can write this in a kind of a weird, what looks stupid, but you can sometimes it's written this way: mg over g, because the mg is the 300. So it's 20 newtons divided by 300 newtons divided by 9.81. And that gets you which is, like you said, 30 point, whatever it is, 9. So this is what you call, I'll say this a lot in class. I'll say you got to get the G out. Get the G out. Okay? That means pull the gravity out of that. I just want the mass. I want the inertia. I don't want gravity. I don't want the weight. Weight depends on the acceleration due to gravity. I weigh different anywhere I go on Earth. I'm walking home from school. I weigh different here at home than I do at school. My mass is the same. Because gravity varies. There's gravity anomalies all over Norman. Parts of Norman you'll weigh more in than other parts. Because of what's underneath us. Sometimes what's above us. That's a different story. So this ends up being, like you say, 30 point something, something, something. What does it end up being? Oh, I got the answer. And I'm buffering. All right, here we go. Ends up being cheating here. I want number 6. The answer is 0.654. Ends up being 0.654. 2 seconds is enough for me. Meters per second squared. Okay, that's the acceleration of the wagon. And then finally on B, it's just at that point it's kinematics. It says assuming the wagon starts from rest, V naught is 0. How far will it move in 2 seconds? Well, this is simply second range. So delta x equals 1/2 a t squared. V naught is 0. So that's just 1/2 times 0.65. Did I say 0.65 meters per second squared times 4 squared seconds. So whatever that is, 1.3 or something. 1.3 meters is how far that Basil will pull that wagon. Okay. And there you go. We'll stop right there. Now we're going to work number 7 tomorrow, and 7 will help you. 7 will help you on the take-home test. So you might want to hold off on number 8 on the take-home test until we do 7 tomorrow in class. So I will be back in about 7 hours to do the prep for the test. All right, so I will bid you adieu. If you want to stick around, we'll talk.
Mr. Askey,
Yeah.
do you know how they're doing finals this year? Is it going to be the same as last semester? Like where if you have an A or a B, you can exempt?
I hope not, but I don't know. I mean, that kind of makes them a joke. Of course, we'll still have our test 7, start test 6. We'll still have that. But then the final part, if they do that, then the final part would be over packet 4 and 5, and I'll make it so that it's not a punishment to those kids that are trying to get I don't know. Good question. I don't think they know yet. They haven't thought that far ahead.
All right. Thank you.
You bet.
It's not a big deal at all. I don't really care, just because like my grade's doing fine. But I was wondering why I got a 0 on 5.8. I turned it in 3 minutes late, so I understand.
No. You shouldn't be. You shouldn't have a 0 on. I don't think I got it from you. I don't. Okay, let me look again. But I remember looking last night at that. Let me look, and there was no, like, it was, maybe you turned it into a different location. Hold on.
Maybe, I don't know. It's
Hold
not a
on.
big deal.
Well, I mean, it's a big deal. You want to get credit. Hold on. Because I remember I was surprised that you didn't turn it in. Yeah, there was nothing there. There's nothing submitted. But let me look across your whole row here. Oh, sorry. Let me turn this. Let me stop recording here. Pause.